Hi from Toronto, my name is John Keogh and welcome to the Future of Food 2021. In this first mini-series of the year, I'm going to talk about food provenance with a whole bunch of scientists from all over the world. I'm going to ask them, what is it? How do we do it? Why do we do it? What are the benefits? And what are the key challenges? And today I'm delighted to have with me Professor Russell Frew from Otago University in New Zealand. Good afternoon, Russell.
Yes, good afternoon, John.
I'm in my Thursday evening and you're in your Friday afternoon.
Correct, yes, about 2 p.m. for me.
Wonderful. So, Russell, for the people who don't know you, I met you previously at the Atomic Energy Agency. For the people who don't know you and the great work you do, can you give us a little bit of intro into you and the roles you have at Otago and also outside of Otago?
Yes, thanks, John. So I have been on the staff at the Otago University for over 24 years now, and I'm a professor in analytical chemistry here. I'm actually a marine scientist, a marine chemist by training. And for probably the last 15 or 16 years, we've been applying the techniques that we look for tracing water masses around the ocean to other natural products, such as food. And was involved with some of the European big projects. And through that, I sort of realised the technologies that were being developed to determine provenance had the potential to be used as non-tariff trade barriers, particularly for developing countries who didn't have the technology. And that's when the opportunity arose for me to work at the International Atomic Energy Agency. They were looking for somebody to set up a program to help train the member states participants in that. And so the university very generously gave me essentially a secondment to the International Atomic Energy Agency, and that's where I first met you. So I've been back at Otago for the last, 6 years now. And I've reduced my time in the chemistry department and am working with a company called Oritain that we founded many years ago, which provides commercial food provenancing services.
That's wonderful. So, Russell, what is food provenance and how do we do it? What's the science behind how we do it?
Yes, well, food provenance is essentially determining where did you originate from? Where did this product originate from? And it's distinguished from the standard traceability, which is more or less like how did it get here? And so we want to know what is its origin. Now, for a product, maybe carrots or something like that is grown in a place, that's reasonably easy to determine. You say that's the garden or the region that it came from. For other products, either like animals, they may move around. And so determining what you mean by origin or its provenance can be a little less clear. But essentially what we do is try to use some chemical measurement on the product itself that is distinctive and distinguishes it from product that's come from other regions. And so if we think of fingerprinting used in forensics, so to distinguish yourself from myself, you can look at the fingerprint and you see there are a number of characteristics on each of our fingerprints that are different between us, whether that's loops or whorls or arches. And the fingerprinting technology relies on making those observations, those measurements of those characteristics, and then defining a pattern that is unique to the individual. And so what we want to do with our food product is make a number of parameters, characteristics. They could be, we use trace elements and stable isotopes primarily, that form a pattern that we can say that, yes, any lamb that has come from the southern part of New Zealand will have this pattern in its elemental structure. And that's different from the lamb that's come from Tasmania or from Wales or from anywhere else. And so if we're thinking of that, the fingerprinting technology, there's 4 basic principles. First, you've got to find these characteristics that do distinguish your product from the others. And you want to make sure that those parameters you're measuring are stable over time. There's no point in defining what your product looks like when it leaves New Zealand, but by the time it gets to the market in Europe or the US, that it has changed. That would not be useful. We want it to be easily classified. We use multivariate statistics for that. And I think the key thing for us and why we use primarily the isotopes and trace elements is that it needs to be a direct causal relationship with what we're trying to identify. So it's environment, it's origin. And that's why the isotopes are so good. It's the annual temperature of the rainfall determines the ratio of things like the deuterium to hydrogen isotopes, the oxygen 18 to oxygen 16. That's taken up by the plants, by the animals grazing on those plants. And that's different in different environments. The trace elements, of course, are derived from the soil ultimately, which is derived from underlying bedrock. Again, there's patterns and differences in different environments that we can make use of that. And so that's essentially what we do. We go out and collect the samples, and we make the measurements. We use the statistics to find what pattern will distinguish and answer the question that we're interested in, and then we do rigorous testing of that just to see how well it performs.
Fantastic, very thorough. That's a really great overview of what it is and also the science behind it. So you mentioned a great example of a sheep and or lambs, and you can discern whether it's from one particular geographic region because of the stable isotopes and the trace elements. And of course, the trace elements and the stable isotopes, they come from the environment, right? It's the water, it's the air, it's the rainfall, and all of these give you that distinct fingerprint. Is that correct?
That's exactly right. And of course, we have to be aware of changes in the environment. So we know that temperatures are changing. We need to have an ongoing program of sampling just to make sure that our fingerprint isn't changing. So that's that robustness, the stability over time.
So I was asked a question today, Russell, and somebody asked me with vanilla. They said Madagascar is well known as the source for vanilla, but Mexico also has vanilla, and they're of the same genus. So if one is more expensive than the other, their argument they were trying to figure out, would that be food fraud if the cheaper one was sold as the more expensive one? Now, I know that's not what we're talking about today, but can you talk about the differences in the trace elements for both of those products? Could they affect the flavor, the aroma, and the taste of those products purely from where they were grown?
Yes, and that is often the question. There's a number of different things in there. So the same genus, so that the genetics, would say, can tell you who your parents are, but it's the isotopes and the elements will tell you where you were brought up. And so that's why it can be genetically identical, but they've been produced in a different area, and so there will be differences in the trace elements that are derived because there's differences in the soil, there's differences in maybe in the farming practices, etc. Now that's the key issue where food fraud comes in, is that one of those products would be valued in the consumer's mind as being better than the other, and so would attract a higher price. If you've got a price differential, you've got motivation for fraud. And I'd say that is the next question about so what we do is distinguish the two, and we make no claims at present about whether one is better than the other. We just say we can say where it came from. There is the current research that we're undergoing, and I've got a couple of students working on this, Now that we're getting these relatively large databases with many tens of thousands of samples in them, we can start to look at patterns within it. And so if you talk to the viticulturists, and they'll say that there's a very small region within a vineyard that produces the grapes to get the very highest quality bottle of wine, even though they're from the same practices. Well, we know that some trace elements are responsible in the gene expression for certain flavours. So there is, we can see there is a reason why you would get a correlation between the element profile and those quality attributes. I don't think it's actually been proven extensively yet, but that's a very interesting area of research and an outcome of doing the sort of collecting the data that we're collecting.
Gotcha. And I'm happy you brought up wine, because I know Australia and New Zealand, you're very proud of your wine. And in some markets around the world, there is a significant amount of fraud with those wines. And in one particular country, allegedly, up to 30,000 bottles of wine, fake wine, sold every hour, according to a Reuters report a few years ago.
Yes.
But that being said, so I keep encouraging solution providers and brands that all of the things that they can put on the outside of the bottle of wine are good, they're valid, they add cost to it, but you really need the science. If you want to verify that this wine is, from New Zealand and from this particular area and of this specific grape, then you have to use science. Do New Zealand producers take a sample, a reference sample of every batch that they produce?
It varies between producers. There are some producers who we would provide some certification for them, and to be able to do that, we need to have the reference samples. So here again is another definition of origin, because you have to treat that as a batch sample. So it's originated from that vat that's been produced from. We can go back and say, well, the majority of the grapes would have come from this region, but we're defining that at that point from when the wine is formed and bottled. And so we keep the bottles, unfortunately, we have to keep them for science, but we have a library of those there that we can make the measurements of. The thing with wine is that it can be in the market for a very long time, and it's not like some other products which you keep for one season. And
of course. I'm a little bit of a devil sometimes, and I tease CEOs of food companies. And if I'm in a conversation with them, although I'm a relatively nice guy and calm, I do throw in something like this, and I go, "You ship products to that country, right?" And they go, "Yes." And they go, "I know. Do you know that 10% of the products that you sell in that country are fake, are counterfeit?" And they always say to me, "How do you know that? Where's the proof of that?" And I go, "How do you know they're not?" So my point to them is that, all joking aside, my point to them is that market surveillance is critical. And on that point, and in your role with Oritain, what are you seeing and hearing from industry as the real benefits of using analytical science to help them bring the best quality product to the market and protect their brands as well?
Yes, well, I think that your last point is protecting the brand. So you have very good producers in every country, and then you have others who wouldn't put as much effort or money into their product. And so some of those quality attributes would be, sustainable farming, using very fewer pesticides and fertilizers, etc., and to produce so that the product that they're putting onto the supermarket shelf is of the very highest quality experience. So consumers expect to have a good experience with that. What we have been doing with once you define what their product looks like, then go and do market surveys where we go and get random audits, and we find out that there is indeed a high level of fraud in the market, and depending on the product, something like the New Zealand kiwi fruit, zestberry, does have a huge issue with fraud. And again, they made their name because the zestberry it's all cloned. So you have a very good control of the quality of the product, but then you can't use the genetics to distinguish it where it's being grown. So, yes, and I think you're also quite right. I don't think it's very rare that fraud is discovered by a chemical analysis. Fraud is generally discovered by some information that raises eyebrows, a change in trade volumes or something. But when that happens, you need then to go for the science to see what is actually going on here. As you said, most traceability relies on labels. Those labels, either paper labels, the barcode, it's been 45 years it's been around now. There's the other QR codes, radio frequency tags, blockchain, whatever you're doing, it's passing information along, generally on the packaging. And so it's very good for checking the packaging, but we say you need to measure the product itself. The truth lies within, and it's the measurement on the product itself that almost certainly cannot be counterfeited. And so that the evidence is there, it's up to us to go and find it.
Gotcha. I love that expression, the truth lies within. And if we layer on top of that the claim from Ronald Reagan, trust but verify, I think they blend nicely together, Russell. So thank you for bringing that up. Now, are there examples of products that you have publicized within the Oritain context that you could talk about? Here's the type of product, and here's how we do anything that's public. I'm not asking you to give away any secrets, but is there anything you could talk about of how you may vary the techniques across different commodities? Let's say you'd have one technique for cotton, you may have another for meat, another one for fish or fruit.
Yes, indeed. So an example we started off talking about with lamb. So lamb is it's a very important product to the New Zealand producers. But if you go to Wales, I think you might expect that the Welsh would consider that theirs is equally as good and probably better. And they've got good reason for that claim. And it is an example of the producers, the Welsh lamb producers. They've put an awful lot of effort into making sure that they've got really good animal husbandry, that they look after their stock really well. So it's low stocking rates, there's low use of veterinary drugs, etc. They take care. Now, to take that sort of care of your animal costs money. And so it raises the production costs, but they get that because they've got the good reputation and they get the returns. But other lamb producers may not be taking that same care, can produce it for a fraction of the cost, slip it into the supply chain and take the additional profits. So we work with the Welsh lamb producers, go to them, first understand how their product is produced, in detail, and then go and collect the authentic samples so that we can measure the variability. So let's say variability is our best friend. If there wasn't a difference between the lamb from Wales and the lamb from New Zealand and other places, then we would have nothing to work with. But variability can also be our enemy, that if we don't sample all the variability, if there was a valley in Wales that we hadn't sampled that was distinctly different, we could get into trouble. So it's getting that reference database is so important. We define, and at this point, you really need to know what is the question they want to answer, and getting some of the insights and the background knowledge is really important at this point. Is it that they want to distinguish their lamb from New Zealand lamb, or is it from France, or is it from Eastern Europe? You know, where do they think their issue is? Because you can use the same data and you use slightly different models to answer different questions, and just determining what parameters, what combination of parameters will make that differentiation. So we get that, we do our own internal auditing, blind audits, etc. And when we can prove that we have an effective system to get our, true positive and true negative rates up to the acceptable level, then we can implement a system where we have, and usually an independent person or a company, go and sample in the market, go to the supermarkets, collect the samples of the lamb that claims to be the Welsh lamb, send them to the laboratory for analysis. We work it up and we say, is this consistent or not? And give them that sort of insight.
So I think that's a good lead into my other question around your neighbours across the ditch, as they say in Australia. And I know that they're struggling with their beef. I know they had a problem with their beef in China with counterfeit. And this becomes a big issue. You talked about earlier New Zealand for the lamb and for kiwi. It's very, very important, not just for a company like Zespri, but also for brand New Zealand. And I did work with MPI, your Ministry for Primary Industries, in the past on the branding and transparency and trust. And they really get it. New Zealanders really get it, whether you're government, university, or solution providers. You have a very tight group of experts, and the knowledge is very high. But protecting the products in the market is very, very difficult. And in the case of Australia, I believe that they started hearing feedback from chefs in 5-star restaurants and hotels that the quality of the beef was deteriorating or wasn't as good as it used to be. And again, the only way to actually verify, as you said, you can put fake packaging around on the outside of the meat. You can test it, and of course for authenticity, of course it's beef. But the key dynamics here is it Australian beef or is it New Zealand lamb? So take off all the packaging, take off all the labeling, test the product and verify. And that's really I think that's a critical aspect of the market surveillance. Now, quick question, Russell. Are the techniques getting easier to do that in market surveillance? Are there mobile tools being developed, or do you still have to use an analytical laboratory in the target market?
Yes, so what we're developing is sort of like a triage strategy. So there are some very good techniques being developed, like even handheld devices that can do a quick scan, near infrared, and other devices like that. They don't have the sort of the probative nature, so you couldn't use that sort of data in a prosecution. But what you are looking for is there something odd here? And I think so. These sort of presumptive tests, a bit like at a police checkpoint for breathalyzing if you've got alcohol. So the first test, you blow into it and it's just detecting, is there something there or not? It's a very quick test, could not be used in court. If it says, yes, there's something odd here, then you come aside, sir, and you do the evidential test then, which then says, can quantify it. We'll do the same sort of thing, that you can use that if you're going around all the supermarkets and you think, I want to collect 50 samples, but how many thousands do I got to choose from? If you can do a quick scan of something along the way or within the receiving company, and then say, well, this one's a bit odd, I better send that away for subsequent analysis, that reduces the costs and it focuses the more expensive techniques to where they are required.
Gotcha.
If I could just come back to what you're saying about the New Zealand being sort of getting this, I guess it's because we export over 80% of what we produce, so it's important. One of the first cases I worked on, probably about 15 years ago, was exactly that case. Some beef that went into the European market, labelled as New Zealand beef, sent for the routine analysis for pesticide residues. In the lab, they ripped the labelling off the rubbish bin, came back at a positive test. Oh, they've lost the label. So the traceability fell down at that stage. That could have closed the New Zealand beef market to the European market. As soon as that happened, the Canadians would have followed, the Japanese would have followed. It would have been a disaster. We were able, when we got the sample back, to disprove the claim that it was from New Zealand. It was not we couldn't say where from New Zealand or where it came from, rather, but we could show there's no way you'd get that pattern within a New Zealand product. And that saved the New Zealand beef market at that time.
I think that's a critical point you're making. So the technology that you've been working on and pioneering for 15 years, it becomes like an insurance policy for not only a brand but for a country, right? That's a great example that you use. But we also had that case, just over a year ago, 2 years ago now, in a year and a half ago, I should say, in Canada with canola going into China, and they claimed that there was some contamination with bugs. So in that case, you can prove or disprove that the canola was from Canada, but you could also look at the entomology of the insects and see where they are indigenous to, which might lead you to conclude that the contamination could not have happened in Canada. It may have happened en route, or it may have happened in the country that's making the allegation. So I really think that the science that you've been pioneering is an insurance policy for brands and for countries.
Indeed it is, and we do work with infant formula manufacturers in New Zealand because that's an issue that they are facing all the time. If they find a whole insect, it's not so bad, well, in the sense that you can use the entomology and identify what it is. Is this one from the country that it was sold into, or is it from New Zealand? But when they find a fragment, it's much, much harder. And so we've developed techniques where we've gone down to minuscule, reduced by a factor of 10 or more, the amount of material we need so that we can do moth wings or parts of moth wings and identify where they come. In that sense, you don't need to have the high degree of specificity that we need. In fact, as our Ministry of Primary Industries said, that if we can give them a 50-50, that's far better than they've got at the moment. Well, we can certainly do better than that.
That's wonderful. And, I think I may have mentioned previously that I was having a conversation on food provenance with my good friend, Professor Robert Hanner from Guelph University. And I'll always remember the story he told me about 10 years ago when he visited us when I was at GS1 in Canada. And he had mentioned a chicken salad in the Toronto area that had a piece of an animal in there. And it was very important to try to figure out where did that happen, because I believe there was 3 manufacturing plants across North America. So the cost of investigating that is huge, but the science that he had available even 10 years ago, he was able to determine that the chicken was from Vietnam and the mouse, it turned out to be a mouse, was also from Vietnam.
Okay.
Which was a sigh of relief, which meant that the contamination, the mouse, could not have come from the manufacturing plants in North America. So it really, I'm so excited about helping people to understand the science, because it really is an insurance policy. And on that point, if you were up in front of 50 CEOs in the food industry today, what would you tell them in 1 minute about the technology and the imperatives for it?
Yes, well, I think it was Warren Buffett who says it can take many, many years to build a brand, and then it's only 5 minutes to destroy it. That this, as you say, that it's an insurance policy against to enable them to prove or disprove claims that against their brand. And so there's that one side. It's buying insurance. Well, people don't particularly like to pay for insurance, but you need to have it. But there is the other side. I think the more important part is that it's an enabling technology that enables them to tell their story about their product. And so we have been working with the Sri Lankan people about their spices and etc. Now, Sri Lanka is such a beautiful country, and they're producing this really high quality product there. And their second biggest earner is, well, before COVID, was tourism. Now, here's a way to bring those two things together, because it's that environment that people come to see is the exact environment that's producing this high quality product. And we can say, well, we get the nutrients and the elements, that's what we measure, that proves that. So you've got the building of the brand and then protecting of that brand. And can the company afford not to have that protection in place?
Of course.
compared to today.
Yeah. Now, Russell, I have a faint memory of you being involved in sequencing Manuka with a Chinese university. Was that you?
I've never done sequencing of Manuka, but we have been looking at authenticating some of the key components of Manuka.
Mm.
So as you are aware, the Manuka, the what they call the magic Manuka factor is methyl glyoxal has been shown, and so that really determines if you've got the sort of the low-grade Manuka, it's up to 400 parts per million methyl glyoxal. Above 400 parts per million, it's worth a lot more money. And we were able to develop an isotope technique, same principle, that could show whether the methyl glyoxal in that honey actually came from the plant and the nectar through that chain, or has it come from some drum from a industrial source. And we did have a successful prosecution a couple of years ago where there was it wasn't a beekeeper, it was a pack house who was mixing a bit of methyl glyoxal in and dramatically increasing the price he would get for his Manuka honey, but quite illegally.
It certainly is liquid gold. I've looked at the prices in the stores and liquid gold, and I believe there's significant more volume of it sold than is actually produced. And I think New Zealand produces about 95%. I think in Australia maybe 5%, if I'm not mistaken.
Yeah, well, that's subject to a court case at the moment where New Zealand is claiming that if it's not from New Zealand, that it's not Manuka. And of course, the Australians are protesting that. So it's before the courts.
Gotcha. That was good to know that. So one of my final questions is around the challenges. So what are the key challenges? I know that there's challenges with regard to adoption. We talked about it earlier. It's an insurance policy and companies don't want to buy that insurance, but I think it's critical that they do consider it. But what are the other challenges? Are there significant challenges on the technical side? Do you have to have very specific resources and advanced technology? So, master's degrees, PhDs, working on the technology, or is it getting better? Is it getting easier?
Yeah, so probably the number one challenge to this is awareness. Not that many people are aware of just what can be done, and so if you don't know it can be done, then you have no reason to adopt it. And so that was part of the work with the International Atomic Energy Agency, was to make the particularly governments and regulators more aware of the technologies that are available. It is true that the technology that we primarily rely on is lab-based, and relatively expensive, and you can have turnaround times of a week to 10 days, which, if it is a food a food fraud, that's maybe acceptable. But if the food fraud involves a food safety aspect, then we really need to turn that around a lot faster because there's people's health at risk. And so speeding that up by making use of these faster presumptive tests and technologies. And it is a data gathering exercise. We're mapping. And so getting more and more data, possibly sharing data a bit more, and making use of modelling techniques to fill in some of the gaps because we can understand the isotopes, what the environmental drivers are. Can we make use of our chemical understanding of those drivers and model what we would expect a value to be, and just fill in the patterns? And so there's a number of different strands of where the development is taking place. I think ultimately we'd like to have instrumentation within production units and receiving stations in the market, and then have data streams coming to be directly compared, which is the dream. That's a few years away, but that's where we're working towards.
Wonderful. And so I think all of this wrapped up together, it really gives producers, certainly primary producers, an opportunity to literally get more value for their product if they're testing it, they have reference samples, and they can pass that verification done by a Oritain or a university onto their customer. Their customer, a retailer, a brand, should be able to monetize that. And I think this is maybe an area that needs to be explored a little bit further.
Yes, and a number of reasons, not just we talked about building the brand, but if there is 10 or 20% fraud in the market and we can halve that, well, that's money that's going to directly to the authentic producer. And we mentioned insurance before. I remember one of the first companies, a big meat company we worked with, when we implemented a system in there, their insurance company reduced their premiums because they recognised they had reduced their risk. Now, the reduction in premiums paid for what the system that we put in place. So I think if the insurance companies are willing to reduce their premiums, that's pretty convincing.
That's pretty amazing. Russell, do you have any final comments, final guidance for companies? Let's say now you're addressing, there'll be 4,000, 5,000, 6,000 people that will watch us when we post this online. What would be your guidance to food companies today?
I would say for the food companies, this sort of technology could be imposed, and we really don't want to see it go down that road because it's just another tax on the producers. And we know that the food producers don't have big margins generally. And but if we can particularly work together and build the databases together, get these systems implemented, we're going to make the whole food supply system more sustainable. It's going to be much more predictable for their marketing, and they're going to open up markets themselves. The technology is there. It's been proven time and again, and there are many companies around now who can provide references to say that it has improved their outcome. I think one of the key things that shows that was working with Oritain. We have well over 100 customers, clients now. We have over a 98% retention of our clients. Once they've used this technology, the value, it proves itself, and they keep coming back.
Fantastic. Folks, there you have it. 37 minutes of wonderful information. As Professor Russell Frew pointed out, education is key. It's critical that a lot more people understand the technology, the capabilities, the benefits, and also how it's evolving and some of the challenges. So one thing you mentioned that's really, really important, and I like people to think about this, the truth lies within. So don't get fooled with saying that software can guarantee provenance. Software will give you data provenance. Science will give you the true provenance of a product. Remember that the truth lies within. Trust but verify. Professor Russell Frew, thank you so much for sharing time with us and sharing your knowledge and wisdom. It was fantastic.
Thank you very much, John. I really enjoyed it.
Thank you.